Okay, so today is sort of the same and sort of different from 3.2. Yesterday, all we did in the equations was which operations happened every time. You either added or subtracted. So today, adding and subtracting goes out the window, and instead of adding or subtracting, it's going to be all multiplying or dividing. But the core issue remains the same. The equation is still like a scale. This is an old-time scale, so they're nice and balanced out. We're still always doing the opposite. And whatever we do to one side, we do to the other. When we're all done, it's always good to check it. Those ideas are still in play. I'm going to look for you to still show me work like we did in 7th grade, and we're still doing in Algebra 1. Today is based on a thing called the MPE. Anybody care to hazard a guess what the MPE is about? Multiplication property equation. Property of equality. There's a thing called the multiplication property of equality that tells you if some stuff is equal, like pick a letter, any letter, A is equal to X, then that would be the symmetric property. For the multiplication property of equality to be true, we need to take equal things and then us have to multiply something in here. Whatever we multiply on one side, you have to multiply on the other. So somebody give me a then that completes this correctly, that you multiplied both sides by the same thing?
2a, 2x.
Yeah, that would be sort of true, but that gives the impression we're only allowed to multiply 2. We're allowed to multiply anything we want. So we shouldn't use a number, we should use a letter, a variable of some sort. BA could equal BX. That would work just fine. That would be a multiplication property of equality. Half the homework, half the board problems over here are going to operate on us having to multiply. What do you think DPE stands for?
Distributive.
Divide.
Property of equality.
Property of equality. That's telling us if
A equals X. What would be A over B and X over B?
that would work. If you have equal things and you divide them both by the same thing, they still have to be equal. I'd have to peek at the book to be sure, but I would guess the book is going to throw on a detail that most books do that tell you B is not allowed to equal one certain number, but it's not a bad idea for me to remind you every once in a while, you're not allowed to ever divide by this number. Anybody think of what number I'm talking about that you're never allowed to divide by? 0. You're never allowed to try to divide by 0 because it just doesn't work. We had that conversation earlier in the year. I think we even had asked our phone. We asked Siri, and Siri brought out a conversation about dividing by 0 and how that just doesn't work well. But those are the ideas behind the scene. The other idea that's behind the scene today is just knowing the rules for multiply and divide. It's handy to review the rules for multiply and divide at the same time because, coincidentally and happily, they are the same rules. 2 positives gets you a positive. 2 negatives gets you still a positive. The only way you get a negative is if the signs are different. So if we get one of each, we go negative, otherwise we go positive. Multiply is always nice too because you just multiply no matter what. It's not like the add problems where sometimes you had to add and sometimes you had to subtract the numbers. There's a difference of opinions there. But that's the ideas behind the scenes. Question behind the scenes? So then here's in front of the scenes. When the number's next to the variable, that means they're multiplied. So our job's going to be to divide. And the most frequent way now that you've entered your algebra career to show division is with fraction bar. So we're going to look to divide both sides by 5. That would eliminate the 5s, because if you multiply and divide by the same number in the same area, that's just a wipeout. X would equal 2. If that's your homework paper, why would I still criticize you gently?
Gotta check it.
Gotta check it. Is 5 times 2 really 10?
Yes.
Yes, so check. Question about that? So this one, are we still dividing?
Yeah.
Yeah. Still dividing? Yeah. Still dividing?
No. Yes.
Yes. Skip that one for a second. Is this one still dividing?
Yes.
Yeah, but when you divide a fraction, we'll save that conversation for a minute. So this is going to be a straight out divide column. I think you said no because you saw the 0, right?
Yeah.
Okay, but you'll see why it's still okay. That wasn't a bad thought, but yeah, I tricked you. Didn't trick you on purpose, but I did trick you. Who are we dividing by in this world?
Negative 3.
-3. Not just the 3, but the negative is like pinned onto that 3 with glue forever. The negative and the 3 have to travel together. So -3 there, -3 here, -3 there. Those -3's wipe out. When you do that division,
4,
-4. And if we check it, a negative times a negative makes a positive. 3 times 4 is 12. It checks. Who's going under fraction life this time?
4. Negative 4.
-4. It's the number with the variable we've got to solve. -4 is with the variable, that's got to go. So -4 divides -4 to get a wipeout. Over here, if you divide all that negativity, it's positive 4. And then checking it, negative times positive is negative. 4's make 16. That checks. Here, what are we dividing by?
X.
7. So the 7's going to divide, the 7's wipe out. 0 divided by 7 isn't breaking any rules. 0 divided by 7 is okay. 0 divided by anything is 0. What is breaking rules then?
7 divided by 0.
If we had 7 divided by 0, which would mean there'd be a 0 with the x. So if I switch this up to say 0x equals 7, to try to tempt you into dividing by zeros, 7 divided by 0 is impossible. It's also impossible for 0 times something to equal 7. That would be a crazy problem, so it should have a crazy answer. Question about that stack? This is multiplying but in disguise. What do I mean by in disguise? What's in disguise?
There's a 1.
There's a 1. Anytime you don't have a number, there's a 1. So if you want to think about this as us needing to divide by -1s, to eliminate -1s and have x equal -9, that would be fine. -1 times -9 is +9, that checks. And I got so excited about the 0 there, I didn't check that one, so doubling back, 7 times 0 is 0, that did check. That would be a way to do that one. Question about that before I go and rewind it another way? Here's another way to think about this one. You know you're done when the x is alone. If x is alone, you're good. There's maybe an easier way to think about this. If you have a negative x and you'd rather have a positive x, you just need to switch the sign. We have a negative x. Our goal is to have a positive x and have the x be alone. So think, the equation's like a scale. Whatever you do to one side, you have to do to the other. So if over here you're thinking, you know, all I need to do is switch the sign, then all you need to do over here is switch the sign. So if you want to step straight to that, just thinking about switching the signs, that's perfectly valid. Here, I might show the division with this symbol, but I might not even do that. I might think ahead a step. We paused here for a minute, a minute ago, because we had to divide by who?
2/3.
Divide by 2/3. If you're going to divide by a fraction, we need to call timeout, flash back to 7th grade and earlier in our life. How do you divide by a fraction?
Flip this up.
You have to flip it. So instead of showing that I'm dividing 2/3, I'd probably rather show that I'm multiplying 3 halves. And over here, show that I'm multiplying 3 halves. This would all cancel. Might make people feel better if I put this
Two,
over
1.
1. Whole numbers are over 1. And then math that out. Can somebody do that over there?
Six over 1.
Or best,
6.
just 6. If we want to check that, if we plugged it in, the 6 would cancel the 3, leaving 2. To multiply the other 2, we get the 4, and that does check out. Question about the dividing part of this life? And we flip on us. Now what's going on the board is not multiplying. The fraction bar on the board means that on the board I am trying to divide, which makes your job in your life to multiply. I'm not going to show multiply 6 like that ever. Why am I not going to show multiply 6 like that ever?
Because that's like a variable.
Looks like another variable in this mix. So I'm going to go dot 6 for multiply 6. 6's cancel. X would equal 12. And checking it, 12 dividing 6 is 2. That sure did work out. Question about that one? So multiply who?
-2.
Multiply -2. So over here, multiply -2. Bump out the -2's.
6.
Total is +6. That does check. Positive dividing negative is negative. 6 dividing 2 is 3, and that's spot on. Question about anything from the first 3 columns? I think I'm about to run out of camera space, and we'll need to kind of swivel it right in my other room.
Yeah.
Question before we swivel? Should be able to just turn it. Thank you. Just capture to there, and we're good.
Yep.
This one, what's our move?
Multiply by 6.
Multiply by 6. So over here, I need to multiply by 6. No more 6's, x equals, and then we need a 7th grade flashback again. How do you take 1 3/4 times 6?
Can you make
Make a
1
mixed
3/4
Make the mixed number into
improper fraction?
improper fraction. What is 1 3/4?
7 years.
7/4. Does anybody need a quick seminar on how we make 7/4 happen? And then if we're multiplying by 6, it might as well go over
1.
1. I like to cancel. Okay, that's a cancelable pair because what can happen to them?
2 goes into the
2 goes into both. 2 and 3. Grand total,
21 over 2.
21 over 2. For homework purposes, I'm going to cut you a break and say if you get a bunch of fraction answers, I'll let you off the hook with checking those and say that you don't have to do it. So plugging this back in, could you take this and divide by 6? You could, but you'd have to write it as divide by 6, which is over a
2 or 1.
1. Dividing would make this.
3.
Dividing a fraction makes it
Boom. Flip.
flip. And it would take us a little while to get that down to 1 3/4. So I'm going to let y'all talk on that. What do we want to do about this one?
Oh, no.
I interrupted the flow a little bit with this one.
What do we divide?
We would divide which fraction?
The 3/5.
Divide the 3/5. How do you divide a fraction?
You flip the same
You flip it. So we'd be flipping 3/5. So we get 5/3 would need to multiply. 5/3 would need to multiply. We had one like this a column ago, and then I like brought it back in a different set. But
That all
it's,
cancels.
that all cancels like crazy. Anything cancel out of 4, 5, 3, 9?
No.
Nope.
So
So
20
over 27.
20 over 27. It's a fraction answer, I won't make you jump. Usually you don't see fractions with decimals in them, but this isn't really meaning it's a fraction. This is more meaning that we're trying to divide. So that's going to be okay. To undo dividing, we're going to multiply. I don't think I would show the multiply with the dot because especially for some of you messy people, the decimals kind of look like the dots. So if I start making more dots in the middle of decimals, maybe that's a mess. Maybe parentheses is the way to go. No, I'm going to multiply by a 0.3. I'm going to multiply by a 0.3, something like that. X would equal, multiply decimals involves counting.
Are we multiplying 2 and 3?
6.
Something to do with 6.
Like 6
Point
decimals.
0.06, because we have a count of 2. We count everybody on the right, we'd be counting the 2. To make 2 decimal places, we need 0.06. I'm not going to make you check the decimal ones either. I mean, you could, but you'd have to check it by like, go ahead, divide 0.3 into 0.06, that kind of stuff. I'm just not going to make you do that. How would you attack this one?
Divide the 5.
Divide with a 0.5. But if we're looking at that, that's kind of an awkward way to look at division. What's a better way to look at it? 1.3 dividing a 0.5.
Put 1.3 in a box and
1.3 in the box.
0.5 outside of the
0.5
box.
out of the box. It makes you
Move the decimal to the right.
move those to the right. 5 into 13.
2.
2 gets you
10.
10, leaves us
3.
3. We're at a dead end, so
2
drop a 0 into it. 5 into 30 is nice. It goes 6, and then the decimal goes straight up. Something about that. One more column. So here's the same concept as yesterday. You could solve this and figure out that x is 2. Once you got the 2, you could plug it in here and do 15 times 2 to get 30. If you want to do that, I won't say you can't because it's valid. I would prefer you not do that. I'd prefer for you to just think in terms of multiply or divide and figure out what they did and match them. So if they turned 5 into 15, this is not adding day, it's multiplying day. If they turned 5 into 15, what did they do? Multiply by 3. So what you want to do is multiply that 10 by 3 and get 30. For this, if you solve for x, it would be a fraction, decimal, mixed number, improper fraction, something like that. So I'd rather not do that. I'd rather just think, they had a 2, it became a -6, what did they multiply by to make that magic happen?
3.
They multiplied not exactly by 3, they multiplied by -3, because the sign switched while they multiplied by 3. So if they multiply this side by -3, just match them on the other side. So 11 is out, -33 is in if you multiply by -3. Something about that. And here's an oddball question. What was this about when we did these? This little,
It like cancels everything inside, or like does the opposite.
something like that, yeah. Anybody remember what those were called? If it was a negative, it turned it into positive, that's true. Anybody else remember what that's called or how it worked? It's a 2-word thing. It's an A and a V. Absolute value. These are called absolute value bars. What they do is they give you the value of a number without the sign. So if you give it a positive, it just gives you back the number. If you give it a negative, it gives you back a positive. I guess occasionally you could give it 0. Let's not forget about 0 not being positive or negative. If you gave it 0, it comes back 2. But on this, we're on the hunt for what x's make that true. Can somebody tell me what x would make that a true story? 5 would work. So would
-5.
-5. Because if we put in a negative, the bars make it positive. If we put in a positive, the bars leave it positive. Absolute value equations often will have two answers. I didn't say always, but I said often. There's usually a pair of numbers, a positive version and a negative version that can make that true. What if I do this one?
Five with a negative outside of it.
Nope.
It's 5.
Nope. I'm being tricky, I mean.
It's because it's called absolute value can't be equal to a negative.
Yeah, the absolute value can't equal a negative. So that sometimes in life, the answer is,
No, nothing.
there is no answer. What's our like symbol for that?
Zero with the line.
It's, yeah, we can use that. We could use the other empty set format. But this can't be answered. This does not have an answer. This is an impossible question. If the bars equal a positive, you're going to get back two answers. If the bars equal a negative, you're not going to get back any answers. If the bars equal 0, you get back one answer, which is 0. But there's, I think, a little bit of the absolute value problems in this tonight, but I'll look at that with you in just a second. Question about these other two columns worth of notes? Here's where we're headed. So homework page is on 104. And we're going to kind of like do what we did yesterday, where I go evens for a while and then skip around. So on 104, we're going to go 2 to 20, just the evens. And then we're going to take a break through the middle, because they do some weird stuff that I'm just not going to do it all there in the middle of this one group. Then we'll kick back in on 28 and skip around a little bit here and there and everywhere. So we're going to go 28, 30, 32, 36. Then that's all still like these. We did a variety over there. Then 38, 39 are going to be this trick, where you have to just figure out what do they multiply or divide by and just try to match them. So 38, 39 are based on this skill. 40, 41, and 42 have to do with absolute value stuff. So the absolute value stuff, there's going to be some with two answers. They didn't do any with no answers. So if you're saying no answer, they're tricking you. The other thing they did on that is they made some of the problems like a little bit bigger. So let me get one more of these. If I said something like x times 2 equals 8, you first have to start off doing the opposite like we did all period. Since this is multiplying 2, your job would be to divide 2. So if you got the bars alone, it wouldn't be 8 anymore, it would be 4. So your answer would be 4 as well as negative 4. So a couple of those in that last group where we're working 40, 41, 42, and that's the end of the row, you have to get the variable alone before you can analyze that. Does anybody know a shorter way that you can write this with a symbol you've not used a lot and maybe have used never? Does anybody know a symbol that we can use for this? I can just write 4 once if in front of it I do this symbol. This means it's positive or negative 4. This is a tricky way to write this. You don't have to write it that way, but I like that little move. This means this, they mean each other, just there's a math symbol for you to use if you wish. 104 again was the page. If I lost you on that, either check the video for a replay of the problems or find your syllabus and just do what the syllabus says because they're listed on there. And then we can give that a shot down on the camera.